Hello guys, in this video I'm gonna do a small demo for how to do continuous time convolution. As we all know, we have two different equations that we can use for our continuous time convolution, and how we chose this totally depends on the two signal we know of. If our signal ht is simpler, since we'll be manipulating HT do all the signal transformation, we'll be using the first equation, so everything will be easier. So same thing, if our signal XT is simpler and HT is kind of complicated, we use the second equation. I will be doing a small demo of this sub-question B in this video. There's two methods to do this question. Since our signal were given, we can plug our signal into the integral and just do the integral using all like mathematic ways. Also, we can draw our signal because we know what unit step function looks like, and we know how exponential gonna manipulate our signal. So we can draw our signal, see what's inside the integral when our signal was shifted and multiplied together, see what's inside and find out the range and just do integral on top of that. So I'll be doing first method first. Since in this case, you can sort of see our xt is kind of complicated compared to our ht, we'll be using the first equation. So our yt will just be our x tau times t ht minus tau d tau, do this integral. And in this case, I want to keep ht. I don't want to plug in ht that early because I saw there's a bunch of unit step function doing summation, so I want to limit the range first. We know how unit step function can limit the range of a signal, right? Because it was 0 when t is negative. And this unit step function is just gonna be shifted, so it was 0 when t is smaller than 2, and for the third term it was 0 when t is smaller than 5. So in this case, I'm just simply gonna plug xt in first. And times ht minus tau d tau. So we can split each term into different integral. Ht minus tau d tau. We have this negative sign over here, so I'm just gonna do negative 2 ut minus 2 ht minus tau. Oh, actually, here we should substitute all t with tau over here. I'm sorry, guys. Always forgot about this step and realize it afterwards. Okay, now we have 3 terms, and we're able to limit the range of our integral by this u tau over here. So for the first one, our range was limited to 0 to infinity. And our second one, the range will be limited to 2 to the infinity. And I'm gonna take that 2 out of here. And for the third one, we're able to limit from 5 to infinity. Okay, so now everything seems simpler. We're just doing an integral on a transform the signal, and we know what our ht minus tau is. Since we know ht is e to the 2t u1 minus t, this was provided in the question. Then we know our ht minus tau is e to the 2t minus tau times e to the 1 minus t plus tau. So if you look at here, our ht minus tau also have a unit step function included inside. So our range could be further eliminated because of this unit step function. And also, since this unit step function was related to t, we were able to find our range for the integral relating to, what exact value our t took. So for a unit step function like this, it's gonna be 0 when the whole thing is negative, and it's gonna be 1 when the whole thing is positive. And we got our ranges tau is smaller than t minus 1, and this one tau is greater than t minus 1. So we know the t minus 1 is actually the boundary for our integral. So what if our t minus 1 is smaller than 0? So in all three terms, this is the first term, second term, and the third term. So in all three terms, if our t minus 1 is smaller than 0, our u of 1 minus t plus tau is always going to be 0 in those three range, because our t minus 1 is smaller than 0. Of course, it will be smaller than 2 and 5. So in this case, first case, t minus 1 smaller than 0, we'll be doing integral on this e to the 2t minus tau, and this unit step function is 1, so we don't need to include it in it. Minus 2 times 2 to the positive infinity e to the 2t minus tau d tau plus 5 to the infinity. And this is just simply integral of an exponential function. I'm not gonna solve the solution for this because it should be easy for you guys. And our second case, let's think about when t minus 1 is greater or equal than 0, but is smaller than 2. So when you consider the first term, it should be 0 to positive infinity and the integral on ht minus tau, right? So it's actually 0 to positive infinity e to the 2t minus tau u1 minus t plus tau. And in this case, our t minus 1 greater or equal than 0 determined, then this unit step function is going to redefine our range. It's going to redefine our range to t minus 1. But for other term 2 and term 3, since our t minus 1 is smaller than 2 and 5, so they should keep the same. So in this case, we'll be integrating from t minus 1 to positive infinity for this exponential function. And then all the other term keeps the same. So now you kind of get to the point like how we use mathematical way to solve this problem and how we find our different cases. So the next case, of course, will be when our t minus 1 is greater or equal than 2 and is smaller than 5. So our first term, still the range is gonna change from t minus 1 to infinity. And our second term is also gonna change the range because now our t minus 1 is greater or equal than 2. That range 2 is, too old for us to use. So you will be calculating an integral. But our t minus 1 is still smaller than 5, so our third term actually stays the same. And our last case is when our t minus 1 is greater or equal than 5. So all the term, their range was defined by t minus 1 instead of 0, 2, and 5. So in this case, our integral will be from t minus 1 to infinity, and the first term and the third term. So when you further calculated all the range, so in this case t is smaller than 1, and in this case t is from 1 to 3. This case t is from 3 to 6. It doesn't matter if you put the equal sign on both sides or on either side, it doesn't matter. So don't need to care about those little details. In this case, t is greater than 6. So in your final answer, you will be summarizing all of the answers you got from all the summation of the integral, and you should look something like this with the first case and with the range, which is t smaller than 1, I believe, and the second case, and with the range from 1 to 3, with your third case, range from 3 to 6, and your fourth case, and range greater than 6. And of course, don't forget about the 0 case. You can say otherwise, or you can say in this case. Oh, in this case, there is no zero case. Because we cover all the range. But, for problems that you don't cover all the range, you miss like a part of it. You can just say otherwise is all zero. So this is basically how we do the first, using the first method to solve this problem. We can also do it in a graphic way, provide you with more visual aid. I'm just gonna copy this problem into a new page. So everything will be clear. So we know what unit step function looks like. So we can actually draw our x signal. It was a signal ut plus a signal with ut minus 2, but it's negative 2. And plus another signal and ut minus 5, and this is 1. This is 5. So you can draw our xt based on these summation of these 3 signals. Starts from 0, have at an amplitude of 1, and when it goes to 2, because of this negative 2, our amplitude become negative 1, and it stays need longer 3, 4, 5, 3, 4, 5, and it stay until 5, and because of this positive 1 over here, it goes to 0. So this is our xt, and our ht is based on u minus 1 minus t. So this is u1 minus t. And then it multiplied by exponential signal, so we can just draw like something like this. We don't need to care what the amplitude of the signal is, but we know it has a tendency of an exponential signal. So this is our h of t. Now recall that equation that we need to use when we solve convolution, and I'm just gonna copy that here as well. So in this equations, our h of t simpler. We use the first equation, so we need to modify our h of t. First, our h of t needs to become h of tau. Where's this? So basically just change our axis to tau, and it has an exponential signal in tendency going to 1. This is e to the 2t. And then we reverse it to h of negative tau. So it will be from negative 1 has this trend e to the negative 2t. Because we reverse it, so t became negative t in this equation over here. And then we're gonna shift to right by t so that it can become h t minus tau. So our signal shift to right by t starts from t minus 1. Shift to right, so t became t minus 1 because right is minus. Oh, I was thinking like what was wrong over here because we're using a axis of tau. Yeah, that was really easy to mess up. So our tau become tau minus t because we shift to right. So tau minus t. And in this case, our tau become negative tau. In this case, tau become tau minus t. Okay, now we got our signal ht minus tau. We know what it looks like. This is our ht minus tau. And we know what our x tau looks like. It looks like, let us check, from 0 to 2 is 1, 2 to 5. This is our x tau looks like. And we're doing multiplication inside the integral. So multiplication inside the integral. Basically, we just put our two signals together and see where it overlaps. That's where we find our range. And it will be clear if I draw this. So we have our x tau over here. Actually, I want to make it to look nicer because we'll be using it as our base. So we have our x tau over here. And think of our ht minus tau is just a signal that, because you don't know what the value of t is, it's just a signal that move along the tau axis, and until some point it encounter our x tau signal, and then we were able to got some value at that range, and we were able to do the integral. So some crazy signals moving along the axis. Think of it the signals as here. Has no overlap, right? This is our ht minus tau. So in this case, inside our integral will be 0. So in this case, our output should be 0. And then the signal move more, and we have this overlap at this range. And now there's something inside our integral. So in this case, since I'm using green, I'm just gonna write here. In this case, it will be our x tau in this inside this integral. So this point will be t minus 1, this green print. So our integral will be from t minus 1 to wherever this endpoint is, which is 5. And our x tau is negative 1. And our ht minus tau is the equation that we solve, tau minus t. And we will be doing integral on this. So the blue one is the first case where there is no overlap. The green one, second case is, oh, we move a little bit. Oh, there is some overlap. And then for the third case is our signal keep moving. Our signal keep moving, and our overlap is kind of different. So we have overlap from this t minus 1, the red t minus 1, to our 5, but we have two different kinds of overlap. We have this positive 1 multiplied by our h signal, and we have this negative 1 multiplied by our h signal. So our third case will be from the t minus 1 to 2, our x tau is positive 1, and our h tau. And from 2 to 5, our x tau is negative 1, and our h tau. I need to find a new color. And then the last case is when our, oh, this is an ugly color, is when our h tau is completely cover our x tau. So in this case, will be integral from 0 to 2. Our x tau is positive 1, and our shifted h tau over here is this equation, and from 2 to 5, our x tau negative 1, and our h tau is this equation. So this is the second method of calculating a continuous time convolution. I find the second method is easier because you have visual aid and you are able to clearly see like what the range is. Of course, in this case, for the first case, will be completely no overlap, so our t minus 1 has to be greater than 5. So in the second case, the t minus 1 has to be within the range of 2 to 5, or else it will be the third case. T minus 1 is within the range of 0 to 2. And the fourth case, t minus 1 is smaller than 0, so it will completely overlap. So you were able to find the range basically by drawing, because our h signal is moving around on the axis because of the undetermined t. And you can see where it encounter our x tau signal. And the important thing in this method is the mistake that I was made at the beginning. So when you do the transformation of signal, remember regarding your axis is tau axis, is not t axis. So this is very important. Your t is just a factor that determine your range. It's just a boundary. It's not an axis anymore. So be careful about that. But to sum up, this is the second method, and the method we talked about before is the first method. Choose whatever method that you like, because if you are good at math and equations and stuff, you might want to use the first one. But if you're easily confused by the unit step function, especially when it was transformed and you don't know what the range is, use the second one, because it will give you visual aid. It's easier to find the range.